This section gives an explanation about the lubricating oil used in marine diesel engines. In a crosshead two-cycle diesel engine, the cylinders and the crankcase are separated, and the cylinder liners are therefore supplied with cylinder oil, while the components in the crankcase are lubricated with system oil. Injected fuel is exploded and combusted in the cylinder, and the resulting thermal energy is converted into kinetic energy. The number of revolutions of a large two-cycle engine is approximately 100 RPM, and the explosion and combustion time is long, which is why low-grade fuel can be used. However, this forces the cylinder oil lubricating the cylinder liners to work under severe conditions of extremely high temperature and high pressure. As HFO has a high sulfur content of about 3 to 5%, its combustion generates sulfuric acid, which causes corrosive wear of the piston liners. Cylinder oil with a viscosity grade of SAE 50 and a total base number, TBN, of 50 to 70 milligrams KOH per gram is used to neutralize the generated sulfuric acid. Cylinder oil is supplied through oil holes in the cylinder wall in conjunction with the vertical movement of the piston. This oil has to quickly spread over the cylinder wall and maintain sufficient wettability. Some of the cylinder oil supplied to the cylinder liner wall is scraped off by the piston rings, and some of the oil is burned with the combustion gases. However, an adequate amount of oil film must be maintained. The combustion of low-grade fuel oil generates gases such as nitrogen dioxide gas, which corrode the cylinder liner, and thus the cylinder oil needs to quickly react with such acidic gases to neutralize them. In addition, the oil must quickly wash away the generated soot and combustion residue from the cylinder liner in order to prevent abnormal wear. Carbon and combustion residue on the pistons must also be immediately removed to prevent this residue from sticking to the piston rings and in the ring grooves, and to maintain cleanliness. Due to the demands of such application, cylinder oil is used only once and then discarded, and waste cylinder oil drainage is discharged from a drain hole at the base of the cylinder. However, a small part of this oil contaminates the system oil by adhering to the piston rods and being scraped off by the stuffing box, and this can result in an increase in viscosity and sludge formation. System oil is used for lubrication of the main bearings, crankshaft, crosshead pins, crosshead sliding surfaces, gears and camshafts in the crankcase, as well as the hydraulic transmission systems, including the rocker arms driving the exhaust valves, and also for cooling the pistons exposed to intense heat from the backside of pistons. Adequate viscosity, heat resistance and stable base number are therefore necessary for the maintenance of adequate reasonable lubricity. Events in the lubricating oil system after bunkering proceed as follows. The necessary amount of lubricating oil is directly supplied to the sump tank from the storage tank. When the main engine is in operation, lubricating oil is circulated via lubricating oil coolers and strainers through lubricating oil pumps. As system oil is circulated during use, the lubricating oil purifier is operated continuously to purify the circulating oil. The oil flow of the purifier is usually considerably reduced to conduct circulating purification. For its part, cylinder oil is transferred to the service tank from the storage tank via strainers using a cylinder oil transfer pump. The oil is supplied to the main engine cylinders from the service tank through filters via the main engine cylinder oil lubricator. As cylinder oil is non-reusable, the oil is discharged to the drain after use.